Okay, this is quiz number 6, problem number 1 on the buff form of the quiz. So the problem is, given the function defined on the domain, the closed domain from -2 to 2, we want to locate all extrema and give all relevant information about the extrema. Alright, so our function is 2t cubed minus 3t squared. So first things first, we want to maximize or minimize, we should take the derivative. Right? At this point, we should take the derivative of everything we see. Okay, 6t squared minus 6t. Okay. Now, to maximize or minimize, well, what do we do with that derivative? Let's set it equal to 0. Okay. And to solve that, well, I factor out a 6t. So 6t times t minus 1 is equal to 0. That's only true if 6t equals 0 or t minus 1 equals 0. So we multiply two things together, and it'll equal 0 only if one of those two things is 0. Right? So add 1, t equals 1, and here t equals 0. Right? So these are possible locations for extrema. Alright. Now, other possible locations for the extrema are the endpoints. So I've got at t equals -2 and t equals +2. These are all places that I could have extrema. Okay? So I'm going to say what kind of extrema they are and give their xy coordinates. So let's start -2, 0, 1, 2. Okay. If I plug these into my original function, now that would be this function up here, 2t cubed minus 3t squared. I'm going to take that, I'm going to plug in -2, I'm going to plug in 0, and I'm going to plug in 1. So 2 times -2 cubed minus 3 times -2 squared. I did not type that in right. Hold on. That's 4 chooses 2. Alright. So that gives me -28. Okay. Now plug in 0, you're going to get 0. Plug in 1 to this function, you get 2 minus 3 will be -1. Alright. And plug in 2. Well, let's change this one. Okay, this gives me 4. Right, so if you're curious where these numbers are coming from, you can look at that. So this is, if you plug in -2 to the original function, and if you plug in 2 to the original function, you get those values. You can pause there if you want to take a closer look. Alright, so that leaves us with, well, what are these values? Are these maximums? Are these minimums? I don't know. Well, we have the extreme value theorem, which tells us that on a closed domain, which we have from -2 to 2, right? This guy right here. I got square brackets, so I include my endpoints. If I've got that, and I've got a continuous function, which we've got a polynomial, then the largest and smallest values in these values are going to be my absolutes. So here, -28 is the smallest number I can get. So smallest meaning most negative. That's going to be my absolute minimum. And this 4 is going to be the largest number I can get. It's an absolute maximum. Okay. Now, as I showed in class on Monday, this is a continuous function, so that means that after a minimum, I'm going to need a maximum, then another minimum. That is, unless these are both neither max nor mins, then from minimum to maximum will be fine. So I still have to check. So what I'm actually going to do is I'm going to use the second derivative test. This is the one we went over actually after the materialist quiz covered, but I think people need to see that one a little more, so I'm actually going to do that. So second derivative test, I'm going to take the second derivative. So first derivative was this guy up here, 6t squared minus 6t. So my second derivative is going to be 12t minus 6. Oops, that's t, not x. So it's going to be 12t minus 6. Okay. Well, that means that f double prime of 0 is going to be 0 minus 6, it's negative 6, and then f double prime of 1 will be 12 minus 6 is positive 6. So I got a negative and I got a positive. So a negative gives me a frowny face. Well, on that frowny face, it achieves a maximum. So at the point where t equals 0, the second derivative is negative. That means I have a maximum there. Since it's not absolute, it's just going to be relative. And here, I've got positive, so I've got a happy face. If I look at the bottom there, well, that's going to be a minimum. Because at t equals 1, the second derivative is positive. It's a critical value, so that must be a relative minimum. And there is all the information I was looking for.